This is going to be a lesson on verifying the line of reflection. We learned in previous lessons that a function and its inverse, when graphed, we see a reflection over the line y equals x. Today we are going to verify that the line y equals x is indeed the line of reflection. I'd like everyone to please turn to page 13. And you're asked on page 13 to plot at least 6 points on the coordinate plane below. So that we all have the same graph, I suggest that you graph these 6 points. So take a second, pause the video, write down the ordered pairs, and go ahead and graph them. So if you did that already, and again, you should have paused the video to write these down and graph them. We have, 1, 2, get that backwards, 1, 2. We have 0, 4. We have 3, 8. We have -5, 4. We have -7, -6. And we have 1, 1. The next thing we're asked to do on page 13 is we are asked, apparently nothing, it's probably, oh, there it is. To switch the input and output values for each point, graph the new points in a different color, list the ordered pairs. So I'm going to take my ordered pairs and switch the input and output values. As a reminder, the x is normally our input, is our input value, and the y is our output value. So when I switch those, I get 2, 1, 4, 0, 8, 3, 4, -5, -6, -7, and 1, 1 is still 1, 1. So I'm going to go ahead and graph those in red. You should also pause the video and graph your points. I'm going to scroll those down just a smidgen. There we go. So -6, -7, and 1, 1. I'm just going to put like a little red dot in that blue dot. Okay, so number 3 at the bottom of page 13 says, what do you notice and wonder about these two sets of points? So take a second, pause the video, think about the blue points and the red points. What do you notice and wonder about the points? No, actually, that's a lie. I've changed those directions to write a conjecture using precise mathematical language about the relationship between the original relation and its inverse. So we should hopefully notice that the red points are a reflection of the blue points. And obviously, if you didn't use red and blue, you should maybe, instead of saying the red points and the blue points, well, just go with whatever colors you have. Over the line, y equals x. And just to reinforce that idea, I'm going to grab my straight line tool. And I'm going to graph the line y equals x. I'm doing orange. Orange. Thank you, Brandon. And here we go. And there's the line y equals x. It has a y-intercept of 0. It has a slope of 1. And if you tilt your head slightly to the right, you can see that if I folded that paper on the orange line, the red dots and the blue dots would line up perfectly. So what does this mean for our task today? Well, today we are going to verify algebraically that the orange line is indeed the line of reflection. So here we go. On page 14, we have some prompts. Statement 4 says, to verify the line y equals x is the line of reflection, we must show that it is a perpendicular bisector of the line segment formed by the original ordered pair, the pre-image, and its inverse. So I want you to think back to honors geometry and what did it mean to be a perpendicular bisector? So if I have 2 points, I'm going to draw them horizontally just because it makes it a little easier, and I connect them with a line segment, a perpendicular bisector is going to do 2 things. It's going to make a right angle, and it's going to create 2 equal segments. So if we're going to do this algebraically, we are going to use the slopes because the slopes of perpendicular lines have a special relationship. The slopes of the line of reflection and the line formed by connecting the original ordered pair and its inverse must be, and then there are 2 words. I want you to sit there, think for a second, what 2 words are we going to put on those lines? We're talking about the slopes. If I take the slope of the perpendicular bisector and the slope of the line formed by the line segment, like if I find these 2 slopes and it doesn't look like this, again, I just drew it horizontally because it's just easier to draw. These 2 slopes must be something. They must be negative reciprocals. Okay, so for example, negative reciprocal, if I have one slope is 2, the other slope would have to be negative 1/2. If I had one slope that was negative 3/4, the other slope would have to be positive 4/3. These are examples of negative reciprocals. This will prove the line of reflection and the line segment formed by connecting the original ordered pair and its inverse are perpendicular. So what we're doing is we're coming up with a plan. How are we algebraically going to show that y equals x is the line of reflection? Well, the first thing we're going to do is we are going to find the 2 slopes, and that will show that they are perpendicular. And then, again, it's the perpendicular bisector. Think to yourself, what do I call this point formed right here? Right where the perpendicular bisector meets the line segment. What would I call that? The blank of the line formed by the original pair and its inverse, the midpoint. The midpoint of the line formed by connecting the original pair and its inverse must fall on the line y equals x to show that y equals x bisects the line segment formed by the original ordered pair and its inverse. So I had this line, it goes like this. I have 1 point here, I have 1 point here. I need to first show using oh, that did not connect, that's okay. First, I need to show that the slopes are negative reciprocals. That will prove it's perpendicular. Then I'm going to show that the midpoint of the line is on y equals x. That will show if it's the midpoint, if something's the midpoint, that means these 2 are equal. Once I have met those 2 conditions, go away. Once I have shown those 2 conditions, that the lines are perpendicular and that the line y equals x bisects the line segment, I can then say I have proven that this is indeed a perpendicular bisector. Okay, so I've got 3 bullet points here. I'm going to follow these 3 bullet points like a recipe. So what I want you to do is look back on page 13, and we're going to pick an ordered pair and its inverse. So I'm going to pick the point, I think, let's see. I'm going to pick this one because I like, this is 2 positive numbers. I don't know, sometimes the arithmetic is better if all the numbers are positive, and the 0 scares me a little bit. So I'm going to pick those 2 numbers, or those 2 ordered pairs. So the point that I'm selecting is 3, 8, and its inverse is 8, 3. So the first step is I need to find the slope of the line of reflection. So I know that y equals x. I know what its slope is. Think for a second. If I have the line y equals x, it's in the form mx plus b. What's the m? What's the coefficient? If you said 1, you're correct. The line y equals x has a slope of 1, which I can also see on my graph because up 1, right 1, up 1, right 1. Okay, so now I'm going to find the slope. I'm going to use the formula m equals y2 minus y1 over. So here we go. The second y value is 3. I'm going to label these up for us. x1, y1, x2, y2. So now y2 minus y1 over x2 minus x1. So I get -5 divided by 5, which is -1. So 1 and -1 are negative reciprocals. If I take the reciprocal of 1, the reciprocal of 1 is just 1. So condition number 1 is met. The slopes 1 and -1 are indeed negative reciprocals. Check. Okay, so the next thing I need to do is I need to find the midpoint of this line segment. And I need to show that that midpoint is on that line. So remember the midpoint formula. So that's the first thing I did was I found the slope. We'll note slope between so the next, that was like my first bullet point. Now my second bullet point, I need to find the midpoint of 3, 8 and 8, 3. I want to remember that my midpoint formula is x1 plus x2 divided by 2. And then y1 plus y2 divided by 2. I'm essentially just averaging the x and y coordinates. So here we go. x1, x2, y1, y2. So that becomes 11, 11 divided by 2. Oh, I only threw a 5 there. And then 11 divided by 2 again. So my midpoint is 5.5 and 5.5. Okay, so the question is this midpoint on the line y equals x? Yes. The midpoint, 5.5, 5.5 is on the line y equals x, because guys, y equals x, duh. So y, cos, you can abbreviate because BC, 5.5, the y value equals 5.5, the x value. So we are ready for our final statement. First thing, and I have to see these good sentences. The slopes are negative reciprocals. The midpoint is on the line. So what does this mean? I'm going to move to typing because my handwriting is starting to get a little terrible. So here we go. The slopes between y equals x and the line segment formed by, we'll go with the order pairs. 8, 3 are, this is a long word to spell, are perpendicular. The midpoint is on y equals x. Therefore, the line bisects the line segment. Okay, so again, the conditions I'm trying to clearly explain using good math language is that number one, the line segment and y equals x are perpendicular. Number two, y equals x bisects the line segment. By showing the midpoint of the line segment is on the line, the midpoint's on the line, that means that line bisects it. You put those two things together, this proves that y equals x is a I'm spelling this in my head every time, guys. Perpendicular bisector of the points, oops, is the line of reflection. Remember, in geometry, we learned that in order for something to be proven as a line of reflection, it has to be the perpendicular bisector between the image and the pre-image. By selecting two ordered pairs from our set, one image, one pre-image, the image being 8, 3, the pre-image being 3, 8, and now showing that the slopes between y equals x and the line segment are perpendicular. The midpoint is a bisector. We now have proven that y equals x is the line of reflection. Homework tonight, those are the answers. Homework tonight is in your packet. It is on page 15. Please make sure you check your answers on Google Drive, or you can honestly just pause the video to where I just showed you all the answers. As a reminder, we have a quiz on Friday.